So in our first epsilon delta proof, we just want to find a delta such that this holds, right? Where to show that the limit of x to the 4 as x goes to a is a to the 4, we just need to start by noticing that we can decompose our right-hand side guy like so. And then if we remember, our goal is to place an upper bound on the difference between x to the 4 and a to the 4. We just need to find a bound for this huge mess on the right when x is near a. So we just say that delta is going to be 1 for now. And remember, this could be 54 or 76, it doesn't matter, just some arbitrary number. And then we see that this implies the absolute value of x is less than the absolute value of a plus 1. And we let that equal b to keep things simple. What we can do now is place an upper bound on the huge mess by plugging in b and simplifying. And then we see that if we take delta to be the minimum of 1 and epsilon divided by our upper bound, we've proven our limit. And yeah, we're done this guy. So now we just want to find a delta such that this holds, okay? Where the limit of 1 over x as x goes to 1 is 1. And so we start by noticing that our right-hand side guy can be rewritten as 1 minus x divided by x. And since the absolute value of fractions is just the absolute value of the top and the bottom, we get this guy, right? Where we flip our x and our 1 because we're absolute valuing, so that's fine. And then we're in the money now. We see another x minus 1 in here, right? So then if we take delta as 0.5, right? We see that x is going to be between 0.5 and 1.5. And so the absolute value of x is at least 0.5. And our divisor is now at most 2. And so if we take delta to be the minimum of 0.5 and 0.5 times epsilon, we see our limit will hold. Now, we didn't do this last time. So notice that this first equality, I've already explained. And then the less than comes from my bounding up there and our delta. And so this limit's proven. And now we're going to do our big boy, right? Our final big bad wolf. I've just combined the last two limits. And now our limit goes to 2, obviously. So first notice that our right-hand side can be split up and bounded into our OG absolute values, like so. And then, okay, we just want to find a delta to bound the distance between x and 1 such that each part of this dude is bounded by epsilon, let's say over 2. So we can just use our deltas from the last two things, right? But plug in epsilon over 2. And we get delta equal to the minimum of these four, where since 0.5 is less than 1 and epsilon over 30 is less than epsilon over 4, that simplifies to our guy on the right-hand side. And finally, I should note this 30 piece does come from plugging in a equals 1 in our first limit. And yeah, we're done.